Hello dear students, we were discussing about module 4, that is vibration methods and grouting. So vibration methods we already discussed. So let us discuss in this video about grouting techniques. So grouting is a process of ground improvement technique. It is attained by injecting fluid like material into subsurface soil or rock. Grouting is a cement, silicate or arsalamide based slurry viscous enough to be poured or injected into soil and thereby fill, seal or compact the surrounding soil. So basically grouting is a process of ground improvement technique by injecting the fluid like material. So grouting we can apply in almost all phases of the construction work. So before construction, during construction, after construction, in almost all phases of construction, this plays a very important role. Before construction, for example, to control water problem, to infill voids, to control settlement, to increase soil bearing capacity, etc. So in during construction phase, to control groundwater flow, to stabilize the loose sand against liquefaction, to provide adequate lateral support. So after construction also we have some application of grouting technique here to reduce the machine foundation vibration, to eliminate new seepage if any, to apply in underpinning work. For the underpinning work is nothing but the foundation works. The technology of grouting is not new. It is not new technology actually, but the materials are coming newer and newer. So the every year we are getting the new materials of grouting. Method is limited to zone of relatively small volume and special problem. So grouting, it is a very limited area we are applying because of the economy. So if you apply for larger area, so the cost of construction work will going to increase. It is adapted to both for temporary and permanent works. Factors affecting grouting, that is grain size and its distribution, permeability of medium, relative density, properties of grouting scheme. So first one, grain size and its distribution. While you are injecting the grouting, so it is sufficient to penetrate. So the grout should penetrate into the ground. So the grain size plays very important role, that is size of the particle and its distribution. Then permeability of the medium. So when you are injecting the grout, it should sufficiently viscous enough as well as it should penetrate into the ground. So the permeability of the medium also plays very important role here. Relative density. Relative density is nothing but it indicates the looseness or denseness of the in situ soil. That also plays very important role. Then we have properties of grout. So selection of grout or the properties of the grout also plays a very important role in grouting process. So we have different types of the grouts there, that may be in the form of emulsion, solution, different forms will be there. So grouting scheme is nothing but the proportions of different ingredients of the grout. Okay, that may be the cement and water ratio, like that, the different scheme. So grout materials, we have suspension form, emulsion form and solutions form. Grout may be these three forms we can use. Suspension, small particles of solids are distributed in dispersion medium. For example, we have cement and clay in water. So mostly we are using cement grout or clay grout which is mixed with the water. So emulsion form, we have two-phase system containing minute droplets of liquid in a dispersed phase. For example, we have bitumen and water. Then third one is solutions form, that is liquid homogeneous molecular mixture of two or more substances. For example, we have sodium silicate, organic resins and a wide variety of other so-called chemical grouts are of solutions. So then we have types of grouting. So there mainly we classify the grouting process into three types, that is penetration or permeation grouting, displacement grouting, jet or replacement grouting. In displacement grouting we have compaction grouting and soil fracture grouting. So first we will discuss about permeation or penetration grouting. So this method is referred, so when the grout is injected, so there is no disturbance to the arrangement of soil particles or soil grains, so that only fill the voids present in the soil medium. So cement grout, bentonite grout or chemical grout are commonly used in this type of grouting technique. So if you see in the figure, so there is a grout pipe is there. So when it is injected with the grout material, so that only fills the fissures in the rocks. In the first figure you can see in the figure A. So second one, or it only fills the voids in the soil medium. There is no disturbance to the arrangement of soil particle. That type of grouting we are going to call as permeation grouting. So cement grout not only fill the voids and reduces the permeability, but also sets with time and binds the soil grains together. So this is advantage of the cement grout here. Hence strength increases and compressibility decreases. So that overall strength of the soil medium going to increase. Sometimes cement in grout is replaced by clay to reduce the cost. So clay having some cementitious property, so along with cement, or we can replace the cement with the clay material. So when the objective of the grouting is only to reduce permeability, bentonite can be used. So when there is not increasing the strength, the grouting objective is not only increasing the strength. If there is only reducing the permeability, we can go for using the clay material, so that is bentonite. The application of this method, if you see here, application of permeability grouting, in the first figure we have the seepage control here. So there is a dam constructed, there is a core, below that we can ground curtain, which is nothing but a seepage barrier to avoid the seepage losses there. In figure B we can see that there is a tunnel work is going on, so there may be disturbance to the topsoil, which we call it as the crown part. Okay, so when it get disturbed, so to increase the strength of that area, we are going to use this type of, okay, so permeation grouting. So other uses also we can do for stoppage of seepage through joints of underground structures such as tunnel lining, basement wall, etc. Second one, we have displacement grouting. If the process of injection displaces the soil grains here, so here there is some disturbance to the soil particle, there is displacement of the soil grains here. So we have two types here, compaction grouting and soil fracture grouting. So if you see the figure here, so this is displacement compaction grouting technique. So the process of injection displaces the soil grain. The method is termed as displacement grouting. The types namely compaction grouting and soil fracture grouting. Compaction grouting consists of injecting a thick viscous paste like slurry at high pressure to form a bulb shaped grouted mass in soil as shown in the figure. So as the bulb forms, so you can expect there is a displacement of the soil particles surrounding that grout bulb. Materials used for displacement of grouting, we have different types of materials we can use. Constituents: soil, that is sand or silty sand with 15 to 30% fines. Cement, up to 25% of soil we can use. Bentonite, which is a clay material, we can use up to 3% of cement. Water, which is adjusted to yield slump of 25 to 75 mm. Grout hole spacing we can use 1.5 to 5 meter. So grout pressure, so while injecting the grout we have to maintain some pressure so that it will uh, form the particular bulb, so that it will displaces the surrounding soil. So up to 4000 kilonewton per meter square we can use. So application of this type of displacement compaction grouting, in figure here you can see there is a thin stratum of soil, loose soil beneath the dense soil. There is a loose soil stratum is there. So when there are different grout holes are formed at different spacing, when you inject the grout there will be formation of the bulb which stabilizes the that loose soil, which increases the overall strength of the soil stratum there. So third one we have displacement soil fracture grouting. In that displacement grouting, second type is soil fracture grouting. A lean slurry of high fluidity is injected into the soil at high pressure to form root-like lenses of grout material in the soil mass. So there is a high pressure grout is injected in the grout pipe, which is sleeved. Sleeved is nothing but the grout pipe is perforated. Surrounding there are holes present. So when it is high pressure, the grout is injected, the grout will be the pressurized through that holes, and that will form the lens for lens like structures there, so which leads to the heaving of the ground, displacing of the ground. So there is a fracture of the soil particles taking place. So grout material spreads all around the grout hole, causing densification of the soil mass. This will cause the ground to heave, and that can be used to advantage. For example, we have rectifying tilt in building. If you see this figure, you can understand. So there is a tilting of the foundation there. Okay. So by using this type of grouting technique injected at high pressure, so there is a formation of lens like structures which heaves the ground and make the foundation straight. Third one we have jet or replacement grouting. So here we have a jet in the drilling rod or the grout pipe. So first step is drilling with water. So it will be drilling up a hole with the water. Second is starting high pressure grouting. So there is a nozzle at the bottom of the that grout pipe, so which will be grouted and rotated and withdrawn. The third step is execution of jet grout column rotating and withdrawal. So execution which involves the jet grout column, that is rotating and withdrawal. Fourth step is repeating for the next column. So this is the jet or replacement grouting. It is youngest of grouting technique. It is more expensive than the permeation grouting because here we are using the more grout material. It is now extensively used because it produces more uniform grouting and can be used in most soils because it forms the base for the foundation construction. In this method, the grout material is injected into the soil mass in the form of a Z to form a grouted column by partly replacing the soil, partly mixing with a remaining soil, also through displacing the soil here. So procedure of jet or replacement grouting. First step we have drilling of the grout hole of 100 to 150 mm diameter. The hole is kept stable by using water circulation or bentonite slurry circulation. Then second step we have commencement of the jetting here. So horizontal direction through nozzle rotated at 5 to 30 rpm. In the rotation we can maintain at the rate of 5 to 30 rpm. The soil cutting travel to the ground surface through annular space provided. Third step, to monitor then lifting of that drill drill bit, so lifted at the rate of 50 to 300 mm per minute, resulting in the formation of the column there. The last part we have grouting procedure. First step is pre-grouting site investigation, then grout holes pattern, then grout characteristics. Fourth one we have grout plant and equipment there. So first, free grout or free grouting site investigation. So before starting or actually applying the grouting process, we have to do the site investigation, because we have to see what is the type of soil present in the field, or different properties that may be required for the grouting process. For example, type of soil, the particle size distribution, permeability of the soil, etc. Second is grout holes pattern, which involves the deciding of the holes diameter and the spacing and the pattern. So that involves the grout holes pattern. Grout characteristics, so based on the soil type, that soil permeability, we have to select the different grout materials. So grout characteristics also plays very important role. Then we have grout plant and equipment. So grout plant, this is the figure which I have taken from ground improvement textbook, ground improvement technique by Purushottam Raj. You can see there is a water meter. So here we have at the bottom we have a water meter there, which which uh, which transfer the water to the grout mixture. So this is the grout mixture. All the ingredients of the grout will be added to the grout mixture, which will be circulated to the third part of the equipment, that is agitator, where there are blades are there to make the uniform grout. Then it will be circulated to the grout pump. Here grout pump is there. So grout pump that will be pressurized the grout, and that will be transferred to the grout pipe there. So the grout which is not taken by this pipe, that will be sent back by the bypass to the agitator again. So it will be pressurized, the grout hole, then which is not taken by this grout, again it will be sent back to the agitator. So this is the basic working of the equipment here. So this is end of the session. Thank you.